Trying to see if...
So how do you raise your hand, just so I know to tell people? There's reactions.
Yeah, if you go to participants, you can then raise your hand.
Oh, I see. Right.
Welcome everybody.
Trying to make sure that I'm actually recording.
Yeah, you're recording now. It's perfect.
Yeah, you are.
Oops.
Okay, so let's get started. Hello everybody, welcome to this seminar in the series of industrial seminars for the Centre for Doctoral Training in AI-enabled Healthcare at UCL. I'm delighted to welcome Mustafa Ghafouri and Adrian Conduit from Hitachi. Mustafa is a former student of ours at the Institute of Health Informatics at UCL, having done the MSc in Health Data Science. I think at the time we gave it a rather ropey name, which we very quickly realised we needed to simplify, and it's now the MSc in Health Data Science. So Mustafa is clinically qualified, but went from the MSc to work for Hitachi and is still there. Adrian, Adrian and I just met briefly before this, but he's a senior director in the healthcare practice at Hitachi and comes to that job with a wealth of experience in biomedical science and healthcare management. So before I invite them to kick off, I'll suggest that everybody keeps themselves muted during the talk. We'll have questions at the end, and I will chair the session, and I'll ask people to use the participants window and the raise a hand option to attract my attention, and then I'll go around and we'll have as many questions as we can. So I think without any further ado, I think Mustafa and Adrian, I'll invite you to take the floor.
Thank you very much. So the talk today is going to be on the practical challenges of operationalizing data science models to improve flow, coordination, and care. So the outline is, first we're going to introduce you to Hitachi Healthcare. So I think for many people in the talk today, they won't know about the work that Hitachi does in healthcare, and it might be a bit of a surprise. And we'll go through 3 use cases of Hitachi working in operational healthcare. And then the rest of the talk, the main bits, will be about the lessons from working in the field. So I know data science is quite new for a lot of people in healthcare, and there's a lot of hype. Seeing that hype turn into something that is actually valuable and is actually can work has been difficult, I think, for a lot of companies, and this is some of our experiences from doing that. Okay. So the first part is Introduction to Hitachi Healthcare. I'm going to pass over to Adrian to introduce some of our use cases of working in healthcare tech.
Thanks, Mustafa, and welcome everybody. First of all, a small apology. One of the challenges of working from home is you're surrounded by other people, and currently the flat next to me is having some work done. I think they're drilling to Australia, and if they strike oil and I go black, I apologize, but please bear with us. I'll try and talk through the background noise. Hitachi, you may know the name, you may think we make televisions. We do quite a lot of other things in a whole range of industrial settings, but the focus obviously for us today is on healthcare. And we are one of only 3 manufacturers of the proton beam technology. I know that UCLH is having a proton beam machine sort of dug out just at the moment. So that's a fascinating area of technology, but in moving towards treatment of patients. And I was fortunate enough to share a forum with the physicist who's in charge of all the treatment planning over at the Mayo. They've got 2 of our machines over there, so an area where we're very closely involved. And Mustafa, could you flick through another slide, please? Okay, sorry, I suppose I should have mentioned a couple of other things. As Mustafa was saying, you may not think of us particularly in healthcare, but we run the National Breast Screening Service for the UK. we're one of the pilot sites for diabetes prevention within the NHS. And we also are involved in a range of projects where we're sort of behind the scenes, where the technology, whether it's data storage and those kind of things, is sort of backing up healthcare. And we're currently working with the American Heart Association, where we've provided them with a precision medicine platform which allows researchers to accelerate research through the various stages so we can get into practice quicker. And as part of the current COVID crisis, we've used the precision medicine platform to create a collaborative space for researchers to see if they can accelerate the research into COVID and use it as a shared space where people can either access research that already exists or bring their own to this platform and share it. And that's working quite well over in the States. A range of things, and I'm sure when we come to the Q&A at the end, if you want to delve further into those kind of things, then that'll be great. Okay, Mustafa, next slide, please.
Yeah, sure. So a lot of our work currently from a data science perspective in healthcare focuses on some of the operational challenges in hospitals. And I think the image there, the comic, highlights it quite well. So there's an increasing demand, particularly in the NHS in the UK, and there is, in general, decreasing capacity. So what this does is causes a mismatch in demand and capacity, essentially the number of people that require the NHS versus the services provided by the NHS. And that causes these sort of operational challenges. There's two other big ones which are really important. One is unwarranted variation in healthcare, and the other is bottlenecks in patient flow. So a bottleneck, a good way to think of bottleneck is, for example, a CT scanner. You might have 10 patients that need a CT scanner, but if it can only do 5 scans a day, then the rest of that patient's care is going to be dependent on the CT scanner, and their care is going to get delayed. Variation talks about providing the same care to the same patients that come in with the same conditions. So I don't know if you want to add to that, Adrian?
Come off mute first. Yeah, I think one of the important things here for the audience to lodge and think about when we come to the Q&A at the end, that thing about unwarranted variation. We'll talk through our use cases, particularly about the program we're doing in the UK at the moment with control centres, that the ability to deliver care in a consistent way based on research to achieve an outcome for the patient which is predictable is one would think of as being a fundamental part of healthcare. And it is astonishing to see the variation, the unwarranted variation that sometimes occurs in a patient's care, and the impact that has on things like the cost of an individual's care or the length of stay. And there's been a huge amount of work done around the world, but particularly for the last 15 years in Japan, on liver cancer, to look at the individual elements in the care pathway and their impact on the outcome. So this theme of the identification and removal of unwarranted variation will be a theme that comes out through the sort of the position the picture we're trying to paint about the role of data science in operational healthcare today. Thanks. Okay, so we've got a couple of user stories here to show how things have developed over the last 4 or 5 years, and where we see the operationalization of data in healthcare in areas where maybe it would have been difficult to see where the value had come, and to paint a story of how things develop. So we'd all like to believe that all developments are well thought through, planned, and part of a logical process. But ever so often we're surprised by actually it's serendipity and good luck that positions us to take an opportunity that previously we wouldn't have seen. User case one is about digital pathology. I was over in Sweden about 6 years ago, working with another part of our organization to digitize histology. The idea there would be to, you'll all know where when a biopsy is taken, the tissue sample's taken, it goes to pathology, it's spliced, dyed, stained, and then moved to the pathologist for a diagnosis. The idea in Sweden was to take a digital photograph of that would make the diagnosis of that condition independent of time and location. And what this is identifying is the kind of areas that we were identifying in terms of what was the analog system, how could we move that into a more digital environment, and how that might then access other areas. So just an indication that over time things happen, and the opportunity to move to a more efficient system and to use digital approaches to the benefit of the patient and the service was a key aspect. So could you give me the next slide, please, Mustafa? What came out from that was to take the example from pathology and see how that might work in a wider environment between some of the areas where the movement of information is traditionally difficult or sometimes impossible because of the way the information is stored. And one of the sort of eye-openers for us in the context of what we'd learned in Sweden, and then bringing it both into a UK context, and to reflect on what's going in Japan, where we run the community services for 3 cities, which cover, in the biggest city is about 1.5 million people. And what we've been able to do is knit together the primary care, secondary care, and social care environments to make sure that all the information is accessible at a single point, so that the practitioner and the family member can access the information around an individual's care, irrespective of where they sit in the care pathway. Thank you, Mustafa. A very quick transition there. My beautiful assistant has got us on to the next one to identify that what we have when we talk about patients' journeys. These are complex journeys. The top line, and this is a slide from the Swedish experience. So if some of the words look a little odd, that's because they're in Swedish. All of the boxes on the top line are the feeder systems that a pathology patient would go through in their journey through the hospital. And what you see, the line that says PEGA, that's a workflow engine, and many of the technologies have moved on since we did this piece of work. So we don't worry about the names, more about the concept of how you collect that information and make it available. But I mean, this slide is up there just to remind people how complex the journey is, how many different systems feed into a patient's journey, and then right at the bottom, the grey boxes pick up all the national, regional and national systems into which that data then flows. You'll see in the longest list, go back one please, I haven't quite finished. Down at the bottom, you'll see the first of the box, the 5th set of boxes says cancer registry. So what you're seeing there is a mosaic that says, how do I treat the individual patient? What technologies might help me collect that information and publish it in a uniform way? And then how do I make sure that information feeds the national and legacy systems, so that we're building up both an individual view of the patient, an epidemiological view of the patient as well. Okay, to move on. Now he slows down. Okay, this is what we're doing at the moment, and shows a little bit of how things have sort of moved on in the last 5 or 6 years. We're currently implementing a control center approach in a major teaching hospital in the Northwest, nearly 900 beds. And the idea here is to create a flow system around the patient that generates the data that will allow us to manage both the individual journey of that patient to the clinician's advantage, but also to give the organization a view of where are they. So in the wave 1 of this, we're creating around the patient journey a view of the capacity of the organization and how the demand is impacting on that organization, and what the hospital might then do as a result of that to change its orientation. Give you a bit of a live one on that. We have, using data science, and this is something that Mustafa has been closely involved in, we've been able to take 5 years data from the historical systems in this hospital and create a forward view, a prediction of what demand is like to look like in a more real-time version than was possible in the past. We're able to layer into that active patients coming into the department, and from that run a prediction of their chance of admission, again from clinical indications, triage data and stuff. And from that, give the bed management team a real-time view of what the chances are of those 100 people in A&E becoming a request for a bed. That can be then fed in, back one please, that can be then fed back into the bed management team. So if they've got a demand for an acute medicine bed, do they have beds available, or are they going to have to start looking at outlying patients, etc.? So that's the way of looking at the demand and capacity of the organization based on data science. What that then moves to is how on admission are we going to look at discharge? So again, using data science and some indicators, we can say, on average, this patient should be with us for 3 days. That's a on-admission prediction. Of course, when the clinician sees that patient on a ward, they will actually have access to investigations. Again, one of those other feeder systems. And that may change the clinician's view from an expected date of discharge to a predicted date of discharge. Then that information back feeds into the capacity model and says, we thought this patient was going to go home tomorrow. It's now extended a day or more into the future. We can now update our forward view of what the capacity of the hospital looks like. So that just gives you a very snapshot view of how using data science and data to help inform the clinical staff of what are they expecting today, what is happening today, of the patients they have in front of them. Here's an intelligent view of how many will turn into admission. And as an admission, how long would they like to stay? And then that feeds all the operational systems and teams within the hospital to make sure that they're working out where are the beds available, and also on the other end, when are the discharges likely to happen, so we can predict when the beds become empty, when we can clean them and get the cleaning staff in, and therefore when the next admission can come into it. So it's a bit like making sure your supply chain, a clinical supply chain, is informed by as accurate a set of clinical data and predictors as possible. Okay, for that slide, thank you.
If it goes forward too quickly, it's just because when I'm admitting people, it accidentally goes to the next slide.
Okay, and here's a bit of a slightly sort of fun example of where this is leading us to in terms of the way things might develop. So looking at this slide, the blue circles in the middle is a pictorial description of the control center, its functions and how it operates. But here what we've picked up is what we call the Uber porter. Now, any of those of you who work in a hospital, you know that there are several bits of the organization without which a hospital could not function. And I'm sorry, it isn't the doctors and the nurses, it's the porters and the switchboard. Here we're just focusing on the porters. Porters are ubiquitous to the organization. They go and collect things, they move people around. And the idea of the Uber porter here is there's an awful lot of downtime for this group of staff because they pick up their jobs from the porter's lodge and they'll get a phone call, will say, I'm in Ward 2, there's a patient he's taken to theatre. And so they'll go to Ward 2, they will move the patient to theatre, leave that patient, and in some hospitals, they will then go back to the porter's lodge, where the next ticket will say, go to Ward 3 and take someone to theatre, or go to Ward 4 and go to theatres and pick up a patient back to Ward 4. What the Uber porter does is pick up a combination of some of the technology we talked about in the digital control center, and also some of the RTLS stuff, the location finding systems that are now being used in hospitals that will identify that porter is by Ward 3 as he's walking back to the ward. So instead of, and that's alerted onto the ward through one of these nice natty touch screens, and so the ward can contact that porter directly and say, don't go back to the lodge, come to me and take another patient to another location. And it's about how you use the technologies and some of the RTLS, the location systems that are now becoming quite popular. And this system is actually working in 150 hospitals in the US currently. How do you use that to improve the flow of activity within the hospital? And we'll be looking forward to taking some of your questions about the Uber porter later on. Happy with the next slide, please.
Cool. So that's part one, and that introduces some of the use cases of how we're using data science in to help improve operational flow. Again, if there's any questions, please do ask at the end. Part two is going to focus more on the technical and how to actually essentially do data science in healthcare, and particularly in hospitals. There's a good reason for this. So there is a lot of potential in healthcare data science. I think everyone knows it. There's a lot of potential use cases, and I've mentioned a few here. However, like a lot of, I guess, technologies, we're part of a hype cycle, and there's a really good paper on this. There is a lot of potential, and thus a lot of people get very excited. But what happens is there is a bit of disappointment as well. And when you get to the reality of implementing data science in healthcare, I think there is, as it's called there, the trough of disillusionment. And we're kind of at this stage here. We're at the point where there's a lot of hype, but the reality is setting in. And I think the true good uses of data science in healthcare are starting to come out. And essentially the question I think on a lot of people's mind is, we've seen data science change a lot in mobile services and other areas, finance in particular. How do we get the same outcome in healthcare? And I think this is a really popular paper, but I think the way we do that is by seeing through the hype and looking at the unspoken challenges of practical data science. So to really, perform good predictions that are actually useful and valuable, you have to see past the hype and see the practical reality of how you implement this. And this is a really great paper, very much on the same topic, called The Hidden Technical Debt in Machine Learning Systems. It's not obviously specific to healthcare, but I think some of these issues and challenges are exaggerated in healthcare data science. So in order to do this, we've got these three essentially principles, three values that you really have to understand. And it goes, know your value, know your data, and know your outcome. And by outcome, I mean the actual, what is the outcome of your work? And I think these three combined, when done right and when done correctly, allow you to deploy actionable data science models and predictions. So if we start with the first one, know your value. So the first thing you have to understand with values, you have to know where your value is coming from. So I imagine a lot of people in the audience today do have experience with data science. I think the most simple way I see it is know what it is you're doing that is going to produce value. Are you describing something? Are you diagnostics? Are you predicting something? Or are you prescribing something? And in general, this isn't 100% correct, but in general, the further you go along this chain, the more value you can produce. So in terms of value, after knowing what it is the value comes from, you need to build a value chain. I think this is one of the most underestimated steps in all data science, but in particular healthcare data science. You need to go from the benefits you're trying to produce, the value, and map it directly to the actions and the predictions and the insights that are being produced. And this is a step that's probably overlooked a little bit when doing data science. I think that people get excited about a project, whereas really you need to say, what is it that's actually going to produce value here, and who's the value going to be for? Adrian, I don't know if you want to add to this slide.
Yeah, I think that's an important point, because as we found in practical experience, sometimes the view of the data scientist is an absolutist one, and actually the end user will perceive more value in what the data scientist sees as a less than optimal algorithm or output, whatever. But in the context of the improvement that's being sought, that is absolutely adequate. One of the things that's identified on this slide is you'll see things like driver trees. This is how the NHS looks to solve some of its problems. So identifying what the problem is and the solution that's being sought is important when thinking about how you're going to design your data science to what is it delivering? What does the service blueprint look like? How is the data science going to inform the change, and make sure that the end user's view of that change is going to be seen as valuable as you would wish it. I say getting that match avoids sort of either aiming for the stars when actually something a little bit less high is adequate, but making sure that you share that with the end user.
Yeah, exactly. And that actually perfectly goes on to point 2, which is the end user. Before we even get to the end user, actually, the stakeholders, you have to know your stakeholders to understand that value. So in particular, stakeholders have to get a buy-in, not just from the data science, but for the value itself. Again, I think this relates to the fact that there's a lot of excitement about producing, the coolest neural networks, when sometimes it requires a back to basics approach. The why of what you're doing needs to be well understood. And I think, the diagram implements it very well. Every stakeholder has a piece of the puzzle, and really these pieces of the puzzle have to come together for success. And I think that's fundamental. And so in order for that to happen, each stakeholder needs to understand the why are you using data science, why are you using predictive algorithms, which take a lot of investment in infrastructure to do this. Just to add to that, I think it's not evil to talk about return of investment in healthcare. And I think it's actually quite fundamental to the long-term sort of survival of and growth of healthcare data sciences. People have to be thinking about benefits, tangible benefits, objective benefits, and so on. In Hitachi, actually, I'll go on to the next slide. So Adrian, if you basically in Hitachi, we also focus a lot on knowing the users, the end users who will use the product. And we do this using a method called user-centric design. I remember my first day at Hitachi, it's the first time I ever heard of user-centric design. So Adrian, I don't know if you want to talk a bit about what that involves.
Yeah, well, the name is sort of fairly self-explanatory, but when Mustafa was talking the last slide, that's a good one because it showed the jigsaws coming together. And it also plays back into thinking about when we were talking about the value of data science, is thinking about what is it that the user wants from whatever it is you're bringing together. And very rarely is it just one element. As you can see from the user stories down here, this is part of our standard way of going in when we're looking at a program and seeing what elements will play best and what the challenges are within the organization. And because there's absolutely no point creating a very complex and detailed analysis for a person who then won't use it. So the stories down here tell you some of the challenges that people are facing for which data might provide a response, or actually they're identifying a problem. And if you look at the top one, it's saying that there's a problem, there's a blockage in the system. And the question then is that blockage in the system because we don't have adequate data about what's going in the area that's blocked, in this case, intermediate care? Is there no visibility into intermediate care, therefore you don't know how to move the people through? Or is it something else? So clearly, one of the questions that rises about the therapist is, do we need data on intermediate care? So that's not a data science question, it's access to existing data. If you go down to number 5 about standardized processes and approach, that goes back to the impact of unwarranted variation in processes. And sometimes just being able to analyze that data is quite complex because it's coming from a number of different systems. So the analytics around the data becomes important, because until you've identified what the issue is, then solving it becomes a bit of a sticking a needle in the haystack. You don't know that you're going to address the right problem. Number 7 is quite a favorite with me because if you look at clinical processes, and when Mustafa was talking about it isn't evil to talk about return on investment in healthcare, he wasn't talking about buildings and stuff. He was also including this, because if you have variation in your clinical practice and you don't know how that's related to outcome, you might be sitting on the best thing since sliced bread in terms of a change you want to make, but the data's not there. Or in some cases, and some of you will remember back to some programs we've done on the BBC, where a guy called Robinson went around the country trying to compare and contrast what was going on. And he interviewed an ophthalmic surgeon in Rotherham whose length of stay for cataract implants was 3 days. When I had mine done, I walked in at 7:30 and walked out at 11:30. That's a variation in clinical practice that clearly had an impact on the investment the health service had to make. So if that had been identified as a new piece of information, one might have looked to try and change that behavior, because obviously behavior is an important part of the how do you make the change that data science can inform. Those kind of things become important, and dealing with those becomes an important part of how the change gets embedded. The bottom one, I think, is also important. Understanding how people build trust into data, because any of you in the room who've ever been involved in a debate about clinical practice, operational practice within hospitals, or benchmarking stuff, is the first thing that happens is people don't trust the data. It becomes an opportunity not to believe the outcome, and therefore not to own any change that's associated with it. So those are important aspects of the user's perception of how data might be used to sort problems out, and occasionally identify problems that weren't known. Going back to number 7, we did a piece of work on cancer waiting times for lower GI surgery in an area, and we identified from the analysis that one of the surgeons did two colonoscopes. That's a variation that had an impact, but didn't seem to be reflected in an improved outcome, and therefore a behaviour that needed to be identified, challenged, and therefore had an impact on the use of those resources. But just to sort of race through a few things, but the title is the important one: know your user. Thanks, Mustafa.
Nice. So this one's actually also very strongly related to knowing your users. Know your assumptions, and in particular, know the actions that will produce value. So this is a bit more of a refined version of know your user, a bit specific to data science. So I think the key theme here is actions produce value, not data. And for a lot of data science projects I've seen, there's this assumption that because it's on the screen, it's in a dashboard, someone's going to action it. That's not true. So that's an assumption. And I think it's one that I think people really need to understand. Ideally, all assumptions in a value chain, if you remember the value chain we'd mapped out earlier, all assumptions would be identified in that value chain. And then you could test the assumptions continuously, not just once if required. Because, you know, there is not going to be any magic steps. If people are not just going to see a value on a screen and react to it automatically. In particular, actually, in some of the work we've done, we've worked with professionals in change management, looking at how people react to what they see on screen and how they change their behavior as a team as a result of that. And finally, the outcome of all that is essentially a story. And Adrian is probably the master of stories. So if you want to add particularly to this bit.
Thank you for that lead up, and now I will fail to meet your expectations. It is really about the story of the patient, how things happen, and I won't refer to this one, but tell you a story that came to us from the hospital we're working at the moment, of a patient called Sally, not her real name, but a real patient, who in the previous 12 months had spent 39 days, not in hospital, but at home. She had oscillated between hospital and intermediate care, had had 8 episodes of admission, 3 of which were clinically justified in retrospect. The story being, understand what is actually going on in your organization, in your hospital, is important, but being able to, just referring back to the story that's in front of us, understanding what are the key limitations to the flow of your patient. The story in front of us here is how is it you actively discharge a patient? Well, it's about knowing what you need to do for that patient. Any of you who've worked in hospitals will understand that there are all sorts of rate limiting factors. One of the stories, which might be mythical in some places, is that of the TTOs, the to take out drugs. In some places, those are ordered at the point at which the doctor says you can be discharged. There's no reason why using an estimated date of discharge or predicted date of discharge or a standard pathway for that patient, that those drugs can't be ordered 2 or 3 days before the patient leaves, if you're working towards a planned discharge. So the story here is, if you know what's outstanding and you deal with it in a structured way based in information and data, then you can actually have a much flatter, smoother progress through the process, and unlikely to cause backups in the system. I certainly wouldn't want to work in the department, part of the pharmacy that's involved in meeting the demand for TTOs, because they're all urgent, but everybody knew that patient was going to be discharged at some point. So why not use the information that's around you to help make life in the TTO department of the pharmacy easier, and also the discharge process on the ward smoother.
Definitely. So I think we're going to get into the more technical parts now. So if you remember, that was all part of know your value, which is the first part of the triangle, if you like. The second part is a bit more technical. Sorry for anyone that's a bit non-technical out there, which is the data side. So know your data. So essentially in data science, in my experience at the very least, there's this thing called big data hubris. I didn't come up with that term. It's a well-developed term, but it applies very strongly to healthcare. And I think the big data hubris is the assumption that data is valuable. Now, that's not to say data isn't valuable, but as the cartoon on the comic on the right says, too much of a good thing doesn't automatically make a good thing. In healthcare in particular, we do now have a huge amount of data, electronic health records, imaging, etc., etc. However, for data to be valuable, you have to have data, it has to be the right data at the right time in the right place. And I don't think that's the case in a lot of healthcare data. And it is slowly getting that way. We're slowly, as healthcare data scientists and healthcare data engineers, we are getting there, but we are a long way away from that, really. And I think once we get this concept right, once we get past the big data hubris, I think that's when you start seeing, a wider adoption of data science in healthcare. Data has a purpose, and I think that's just always good to keep in mind. The second part about data is know the 70%. So the data science that I think people see is the tip of the iceberg, and to have a successful project, there's all this stuff underneath, a good chunk of which is done by data engineers, but it's something that data scientists, data engineers need to work really closely to develop, because if you like the previous slide, if you don't have the right data at the right time, the right place, you're not going to be able to produce the right predictions that will produce value. And this 70% is a lot of the essentially a lot of the tasks and some of it that is not really talked about in the sort of glossy magazines, but it's fundamentally important. Kind of related to that, you need to understand data availability. So a good lesson is just because data is available in a database does not mean it's going to be available to service your model when you require it. And there's, I've written down here some of the challenges of why data may not be available. A good way to get around this is actually to work with the data engineers to develop a master data management system that that works with the data science, and if possible, use same source and same data to train and deploy your models. It should, from the get-go, that should be a principle that's stuck to, really. It's not to say that that's never deviated from, but if you can do that using master data management, it's probably advised for a good amount of the cases. Kind of linked to this, know your operational data systems. So these are sometimes called legacy systems. I think operational systems is a better word. And people might recognize these as electronic patient records, electronic medical records, administrative systems, so patient administrative systems, and so on. These have been around for about 20 years, some of these systems. They were designed when technology was in a different era. And it shows when you use data from some of these systems. It's not to say they're bad, they're perfect for what they're designed for, but they were not designed for us to be able to predict demand in a specialty. They're not designed really for dynamics, business changing rules where, A&E looks one way one day and looks a different way after COVID. I think for a lot of the projects, you're going to need these operational systems. However, how to work with them, particularly if you're working directly for a hospital, is really important. I know from my experience at UCL, it's quite different if you have, linked databases. If you have linked databases, it's a slightly different story. But for those working directly with hospitals, I think, make understanding these operational systems a priority from day one. You might get a bit of pushback. You might get people saying, why do you need all the data from EPR? Why do you need all the data from PAS to understand it? But I think understanding these systems and then understanding their architecture and how data can be provided from these systems and the messaging protocols and so on is really fundamental. And just put the bottom there, IoT devices, application-based activities can then be used actually as alternatives where possible. So if you look at some of the more successful applications of healthcare data science, they don't use operational systems nearly as much. They use, for example, apps on people's phone, or they develop sensors that people wear, such as mobile health. And these bypass some of the challenges that you get with operational systems. know your data dependencies and know the threads. Your data the data servicing your model will have upstream data dependencies. Wherever possible, audit and test all these dependencies. And even when you audit and test it, new stuff will come up over time that you just didn't expect. You know, they might start measuring heart rate in minutes. Okay, that's a bad example, but the unit of measurement might change, or a business process might change, which means the way that data is collected is very mildly different. All of a sudden, it's going to completely impact your model because the units that your model gets is changed. So these upstream data dependencies are challenging in themselves. One way to potentially get around this is to make better use of longitudinal health records. That is essentially indicate patient journeys as part of your master data management system. And that can help structure your data in a way that's, particularly in hospitals, as it might be a bit more friendly with regard to data dependencies. But there's no easy answer. Again, this is something that data-wise should be a priority from day one. Cool, so that's a lot of the data stuff. Again, if you have any questions on that, please do ask at the end. I think we're moved faster than I expected, actually. So lastly is know your outcome. And here it's basically what's the outcome from the piece of work you've done. Is it sort of a script, a Python script that's going to run at a certain time? Is it an API, a web service, etc.? And knowing the details of that. Again, it's a bit technical, so sorry for anyone that doesn't work with this area. So non-functionals are incredibly important and underestimated with regards to the outcome and the product. If it's a product, if it's not a service, for example. But assuming it's a product, you have to understand your non-functionals. Non-functionals can make or break the value that you expect to get from your predictions. So when is the predictions called? What's triggering the prediction? Is it triggered by an event? Is it triggered by time? What is the impact of these characteristics, these non-functional requirements on the business process, particularly lags, for example? Is there a data dependency that means it's going to have an impact on the business process? One of the, I think, biggest sort of trends in the last 2 years, and it's not just been from ourselves, it's been from some of the other big tech companies, is moving to understanding the importance of near real-time data science versus data science that isn't needed in such a short period of time. And I'm sure that's being seen in quite a few companies at the moment. Particularly if it's a product, can it be maintained? So deploying a model quickly is not too difficult. Maintaining it is challenging. You need infrastructure for that, infrastructure for monitoring, infrastructure for maintaining accuracy. And then, how do you develop the use? Is it reproducible? Is it scalable? Regarding the product, similar to before, how are people going to interact with it? So as you can see in the comic there, some brilliant dashboards out there. It's no good if it doesn't impact anything. And this particularly relates to kind of a theme, which is understanding the data in relation to the patient journey, and understanding the outcome in relation to the to-be process mapping. For those that aren't familiar, you do an as-is process mapping, and then for certain methodologies, you do an as-is process mapping, and then a to-be business process mapping. And where does your product or service relate to that? And finally, an additional one is understand the ethics of what you're doing. There's a lot of challenges with regards to self-fulfilling loops. You might predict something, and then by preventing it happen, you make it non-measurable. There's a lot of ethics around, even for non-medical devices, around predictions. So understanding that is always healthy. Again, getting quite more focused on the data science side, understand your overfitting. Don't oversell your prediction. You're going to miss stuff. You're going to get stuff wrong, no matter, unless it does depend on the details, but a lot of time you will miss stuff. I've put black swan events, but in general, you will miss stuff. Sell your model as statistics, as a probability wherever possible, and communicate that adequately. Particularly communicate your performance metrics adequately to your stakeholders. if possible, understand which patient groups or which scenarios your model does or does not work in. So if it only works for patients coming in through A&E, because that's where all your data is, make that clear. A good example of this, and I'm allowed to say it because it's Google, it was Google. So those that have been in healthcare data science for a while will know about this. It's the Google claimed back in 2013 they could use deep learning, I think it was, to predict flu seasonality. It was very useful for public health because public health doctors started saying, so Google was predicting flu seasonal peaks 2 weeks before they occurred, which was very useful for public health measures in relation to vaccines, I think, and other stuff around that area. They got it, they missed, not only did they miss the peak in 2013, they got it wrong by 140%. If we depended 100%, if we depended on that Google flu trend, it wouldn't have been useful or good for patients. So I think these sort of overfitting biases are really important to understand. And again, the comic, quite a funny explanation of that there. And finally, I think there's entire books around this. And if you have never heard the term technical debt, read the paper that I referenced before about technical debt, and get an understanding of technical debt, particularly technical debt in data science. There's a lot of maintenance around data science models, a lot of stuff about data ops, so data operations, what's called now machine learning ops and machine learning engineering, and then all the business logic that comes around that as well, and the infrastructure that comes around that. So you can either plan now for all the maintenance that's going to happen and take the extra time, effort, and investment to prepare for that, or it will drag on you once your models are deployed. You don't want to be going out every few weeks to reservice a model for whatever reason. You want to be thinking about this stuff prior, thinking about how things are going to essentially lay out and preparing for them wherever you can. It's not always possible. It's, you know, it really isn't, and it's a very difficult thing to do. And I don't think there's any best practices for managing technical debt in data science. I think they're developing, a lot of companies are developing them. In healthcare, because of all the operational systems, it's incredibly challenging. But I think, as I said, we're at that point where reality is hitting in and we're understanding some of this stuff at a much better level. And that's the main point. So in conclusion, I think what we've talked about, particularly from the lesson learned, is to know your value, to know your data, and then to know your outcome. What that ideally should translate to is a business architecture, a data architecture, and a technical architecture. These three things combined, when done well, will hopefully make success much more likely. And again, I think a big lesson is don't underestimate the investment. It's not a quick model. It's not, you know, take something from academia and just throw it in there. There's a lot of infrastructure and a lot of time required to invest to make any of these, well, most of the time, to make these predictions work. Thank you. And just a little leaving message there. The only way it's going to work, the only way we're going to implement successful data science in healthcare is people welcome change, but they accept change as an investment worth making the time and effort. Thank you very much. And I think we'll move on to questions.
Yeah, great. Thank you very much. So I'll give people a second or two to think of their questions. And I'll just remind you that what I'd like you to do is go to the participants button at the bottom of the screen, and that will bring up a panel that you can then use to raise your hands, and I'll flick through people as they raise their hands to come up with questions. But maybe I'll, oh, okay. So Nidita, do you want to ask the first question? You've come to the top of my list.
Yeah, hi there. I have
Could you quickly say who you are before you ask the question?
Sure. So I'm Nivedita Bijlani. I've actually applied for the AI for Healthcare CDT, you know, for the September-October intake this year. And I'm a data scientist freelancer. I'm also faculty assistant for a remote faculty assistant for a US college in their graduate program for data analytics. So that's me. I have a couple of questions actually. You can take them in whichever order. The first one is, what are some of the challenges around integrating with legacy systems? I think Adrian showed the slide on the complexity of the Swedish implementation. And I was just wondering because, clearly as a data scientist or a solutions provider, you are not really in control of the interfaces for some of these legacy systems. So, the first question is, what are some of those challenges? And the second one, I think, is for Mustafa in terms of the data science bit. If you could shed some light based on your experience on how these models are monitored and kept updated in a healthcare setting. How are these retested? How are they continuously monitored? Thank you.
Okay, so, yeah. Thank you, Dita. That was two good questions. The first one about what the challenges are. Well, clearly, they are, as you say, of integration. And the fact that in the healthcare setting, we're tending to look at messages that are written in the HL7. And that is the common format. But of course, what we're finding in the real world is that any number of different formats for those messages are in place, and some quite challenging interfaces have to be written in order that the messages that it's very easy to say, oh, you just need to get a message from the laboratory information system through to the control center, and we'll know where all the investigations for these patients are that can facilitate their discharge. And then you look into the actual technology of it, and the message is not available in the format you want. So you have to build the interfaces. And I think that because we're sort of this is a fairly new area, I think what we're going to see is there are some challenges in the early adopters, as is often the way. But the building of these interfaces and building up the catalog of them will mean that over time that there is more of a data integration catalog to go to. But it is without doubt one of the biggest challenges where we are at the moment. We've identified something in excess of 100 data points that we need to create the integrated control center model. And so far, I think we've identified about 25% of them that are doable, but only about 5 are actually HL7 messages at the moment. So there is a big challenge, and that point that Mustafa was making about understand the challenges and the investment required to overcome the challenges is a key part of that answering that question in a coherent and sensible way.
Yeah, I just want to add to that. Buy-in is required from the hospital. So again, the database management team, the BI team, sorry, is fundamental because they understand their legacy or operational systems really well. So they'll give you the initial insights. I think understanding the operational systems in detail. So understanding the process that they go through to the best of your ability, and that's not obviously always doable, but it is essential to know at what point your services can fit in best. So there's a lot of working together, and if you don't, you need that buy-in from the people that know those systems, and can give you that insight. In relation to your second question, testing and maintaining data science models, again, best practices I don't think in general for data science have been developed for this, let alone at healthcare level. I think monitoring is accepted now that you need monitoring. I don't think all the challenges really are documented very well that you get with monitoring, particularly with feedback loops. So a lot of you end up maybe predicting something that changes in action, that then means you can't monitor very well. These sort of challenges in monitoring, I think, needs more research. So maybe Professor Taylor, you can have more academic research in this area. And testing, I think testing, what we've done is we've learned, obviously Hitachi's a software development, like it's a technology company. So we have a lot of software development people, and we've applied a lot of standard software development testing as much as we can. to the data science. I think there is a good relationship between data science is essentially standard software development plus extra. So if you know, in order to be a good data scientist, really, that writes software, you need to understand standard software development and then understand the additional bits. And I think that's where we've kind of gone with this. I hope that answers your question.
Great, thank you. And Andre, I think you're next.
Hi, how's it going? I'm part of the UCL CDT.
Do you want to quickly say who you are, for people who don't know?
Yeah. My name's Andre. I'm part of the UCL CDT. I basically just finished my first year, and I worked in healthcare data science before I joined the PhD program. And for me, I think I'm interested in first of all, like in the applications you've made in Royal Salford. We know how far along are you in that process with them? What part of the value chain are you targeting? Just going into a little bit more detail on those applications would be really interesting, because there's so many different projects in the NHS using healthcare data analytics and data science, and it's just interesting to see which ones have gained traction and are being found a lot of return investment. And then I guess I think that's the main question I'll ask actually. Those are questions I have, but yeah.
Okay, you can ask another if you want.
Well, whilst he's considering, I'll dive in to answer the first bit. I think that there's a good catch-all phrase that came from the hospital, which was looking for actionable insight. The slide that Mustafa showed earlier about a plethora of data, which isn't the same as information, can sometimes confuse and allow you can't see the question that you need to actually ask and answer. So part of the test for us was to be able to look at providing actionable insights. And that's a sort of underpinning philosophy. And the way that then translates is, when I was talking through some of the user stories, we have 5 data science-based products, if you like, that are going out into the first wave of the deployment in this hospital. And they are about providing actionable insights to demand. What's coming into the door, and therefore, how do I need to respond to it? Capacity. How much space have I got for this demand if it all turns into an admission? Prediction. Of the people who are coming my way, what percentage of those people are likely to be admitted? Discharge. How many of the people in my hospital today are likely to be discharged today? That will then liberate capacity that then I can put back against my demand and provide an actionable insight as to whether I need to open extra wards, whether I need to declare a high-level emergency about capacity, as we've seen with COVID for some hospitals. Do I need to open another X-ray suite or get on another CT scan online? So the answer really is data science applied to providing actionable insight through these different sort of capabilities is a fundamental. And sometimes it's about how you can provide the data to change the behavior. So one of the areas that we looked at quite specifically when Mustafa and I were working before the program started, looking at some of the analysis, we looked at frequent attenders. Now the college definition of a frequent attender is someone who has attended the A&E department 5 or more times in the last 12 months. So I just let that little fact to. And that group of people represents 15% of the people who are turning up at A&E. Okay, so 15% of the thousands of people who turn up every year have been there 5 or more times a year. Trouble is, when the clinician sees that patient, they've got no idea that patient has been, I'm going to keep putting my hand up, 5 times or more in the last 12 months. And actually, if not only they knew that they'd been that many times, but they were the Sally that I talked about earlier, who of the 5 times she turned up, 3 of them she ended up in intermediate care. And if they'd had access to what the capacity was in intermediate care, they might not have admitted her after the appropriate clinical investigations, but they might have referred her directly to intermediate care because that's where she normally ended up. You can change the behavior. So if you do the maths around what data science had presented, or data analysis presented, is it allows you to look at 15% of the people who are consuming a disproportionate amount of A&E time, and those 15% of people turned into 21% of the admissions you can look at the bed days, and stayed a disproportionately long length of time, even though they then tended to go to another facility that wasn't an acute facility. So in terms of being able to provide information, to provide an actionable insight about a clinical group of people who are very regular attenders, who are consuming significant amounts of healthcare resource, sometimes not to the best outcome. And that's where you can use the data science to target those actionable insights and deliver a real value to the service, because once people are in the system, as those of you in hospitals will know, it's quite difficult to get people out. Part of our phase 1 work was to talk to, they run an integrated care organization there, which means social care is part of it. And we brought this director of social care in to show them the process map of the whole hospital. And they said to us, if we as social care can intervene at this point in the care process, we can get a care package in place for that patient within 3 days. And I'm quoting now, if you leave it to this part of the process where they've been admitted, it'll take me 21 days. So you just added 18 days at nearly £600 per occupied bed day to get the same outcome. So those kind of insights have a definite, if you like, ROI to the healthcare, but also to the care of that patient. They spent 18 days in hospital when what they really needed was a social care package.
So just to add to that, that's a really good point. I think the way Adrian talks about bed days and return investment, I think that's a big thing as well. So I remember, again, what Adrian's talking about is what we call phase 0. We were doing some analysis. You know, I didn't think it was bad to do our analysis on bed days, which is a bed day is like 1 day in hospital for each patient, and to look at the value associated with that, the cost and the hospital, and look at you know, how much it costs for a patient and how much bed day takes and so on. That sort of analysis to be able to correctly produce the return of investment, I think was helpful, and particularly regular attenders, was able to get us to basically produce the numbers required to understand the impact for that area of healthcare provision.
Yeah, that's interesting. I think so. I think one of the challenges I've come across in similar pieces of work is there's that first stage where you identify, you know, a costly group of patients, but then it's like, how do you actually implement a package to identify those patients before they go on to create those costs?
Yes.
And that's when you start to get into even more expensive things, like you mentioned before, like, you know, trying to orchestrate the data so you can actually identify the people before they become the problem. Yeah. Or you take the alternative approach, which is kind of where you just try to change the system globally rather than identify individual patients.
Yeah,
I think.
Yeah. No, go on. Sorry.
Yeah, I'm just interested. So I guess you must be trying to do both, because you describe both, but
it's even broader than that, Andre. You make a very good point. We focus as a country, I think we focus about what's going on in hospitals. And if you think that 70% of the total spend in healthcare is on long-term and chronic conditions rather than, you know, blue light stuff, then we need to put more focus into what the pre-care, if you like, the primary care stuff and what's going on in community, both before the hospital episode and afterwards. And the original model, and if you like, the integrated model for control center is something that actually starts in the community and starts monitoring those groups of people with long-term conditions who are already unwell. They have a different threshold than the fit person. And what the challenge in the community is managing their care below that threshold, because if they pop above that threshold, they become an admission. And what we do know is once they become an admission, then the chances are, unless their discharge is facilitated very quickly, they tend to leave the hospital in a worse state than they arrived, because the very nature of their condition doesn't make the acute sector the right place to be looking after them. So that thing about using technology, and whether it's remote monitoring, telehealth, etc., to manage these large groups of people with ongoing chronic conditions. And I'm sure someone in the audience will correct me, but I think there's something that says by the time you're 40, you've got one long-term condition. By the time you're 80, you've got 3 or 4. So the longer we live, the more these become the population we're looking at. And we all know how the age profile of the population is going. And one of the advantages of working for Hitachi is because we're a Japan headquartered basis, they're streets ahead of us with the impact of the change in demographics. So they're already ahead of the thinking about how you deal with that. But that's about understanding the community, because the hospital is the result of the things that go on before that, and just dealing with the problems in the hospital is not the complete answer. You have to start looking at the, if you like, the supply chain of patients, your order book out there, that if you don't monitor and look after those people appropriately and accurately, you have an impact on the acute sector, but also the quality of life of those people.
We're beginning to get close to the end.
Oh, sorry.
I want to encourage anyone who's got a question to raise their hand.
Can I just add?
Stephanie, I've got a question from Stephanie in the chat. Stephanie, do you want to ask your question audibly?
Yeah, sure. Hi, I'm Stephanie. I'm a researcher at Microsoft actually, but I work in machine learning for healthcare. So I was curious about data drift. So from the machine learning end, I feel like data drift is something that people are very there's no consensus even on how to identify that data drift is happening, and therefore like how you can build a model that will be robust to that. But obviously there's a big gulf between the research world and the practice world. So I'm wondering, since you mentioned it, could you comment about the kind of, how do people deal with data drift in practice, if at all? Or maybe it's not a problem, I'm not sure.
It definitely is a problem. It's definitely a problem, like I think I've said before, that best practices are not developed for. I think the approach we've taken is try and be as practical as possible and don't be a perfectionist. I think the biggest challenges we've had is with some of the loops and where you can't accurately monitor certain data drift because of a loop that you've caused yourself. Where possible, though, we've just used, I don't think anything too advanced, just monitoring, essentially, monitoring what we're doing, what really happens, comparing them, and seeing how that changes over time, which I think is that's nothing too complicated. Where I think things get more complicated is when you're not able to do that. There's also a thing about how do you then address the drift, and I think that's, again, on what level of manual to automated do you go? And it's not black and white, it's not all manual and it's not all automated, and there's almost like a scale, and at what point on that scale do you place yourself? And it's not where do you place yourself as a company, as a person, it's where do you place yourself for that specific problem that you're trying to solve. But I'm sure you probably have quite a big experience in this area yourself.
It's always interesting to get perspectives. Yeah, no, thanks for that. Yeah, I do think it is a kind of a question of seeing the model performance changing. I wonder if I can have a follow-up question. How do you deal with maybe the sort of regulatory compliance around this? This is a kind of big question in machine learning as a medical device. If your model performance is starting to go down over time, how do you say that you're still using the same device? If that makes sense.
Don't be a medical device. It's the easy answer. Don't, wherever you can. Obviously know in details requirements and the ethics around your model, but don't, being a medical device obviously is probably where things ideally will go in the future, but where possible, if you don't need to be, and a lot of the operational stuff luckily doesn't need to be. But I can imagine for a lot of the sort of other areas of data science and healthcare, you have to be a medical device. So I think that's treated separately.
I had a sort of question, slightly a follow-up to that, and specific to the data drift thing. It was occurred to me looking at some of your stuff that with COVID-19, obviously during the emergency, everything is very different.
Yes.
But it might well be that after the emergency, some things don't go back to normal. So it may well be that behavior, obviously diseases stay the same, but people's behavior around seeking health and whether or not they go to A&E or go to their GP, that may permanently change. So that, how do you deal with that in a
luckily
algorithm for predicting length of stay?
Yeah, so with length of stay and some of the other models, it's slightly different, but luckily for demand, we are, without giving too much away, we're regularly retraining, as in very regularly, and doing just the best you can. It's a part of this is mathematical, and when you retrain, what data you use to retrain, and so on, and hyperparameters you use that best adapt to these sort of situations. Another part is the stakeholders and having that, honest discussion, not overselling with your stakeholders about COVID. For example, for each of our reports, we put a big warning sign after COVID saying, look, this particular report uses X amount or doesn't use COVID data, and this is going to be required to adapt to COVID. And that's what goes out to the stakeholders. Sorry, Adrian, were you going to add something to that?
No, I think that's broadly it. But as Paul says, we're in a new environment. And some of that environment obviously challenges how behaviors will change. The interesting thing is, and I suspect psychology will come into this as much as data science, is on the one hand, the NHS is saying that you won't be allowed to go to A&E unless you phone up 111 and almost get a barcode for going. A&E will be locked. But you can see that to support that, people's behaviour has to change, and whether we will change what happens in A&E and have GP streaming at the front door to put people back to primary care, and whether if there are mass referrals out to primary care, either through 111 or GP streaming, whether those referrals will stick or whether they'll end up back in the acute unit. So I think it's very much a case of we're going to have to look at the data as it starts to be assembled to see whether there has been a radical change, and therefore that updating of machine learning is going to have to be on new data sets that are being compiled as we speak, or whether actually there'll be a hybrid where COVID will continue to have an impact as it will be with us as a disease, as it mutates and changes, but actually that human behavior will either completely change or to some extent. And that I think is one of both a challenge and a bit of an exciting area to see how this does change the way people use services, how data is generated, and whether in fact that is a national thing or a regional or local impact, and whether our data models are going to change quite significantly.
Yeah, that's actually a really good point. It kind of relates to Andre's question before. New models of care are being developed. So you're going to have to adapt to these new models of care, and you have to be involved in them wherever you can. And Adrian has a lot more experience of this than I do, but for example, with COVID, new models of care have been developed at all levels, at the government level up to down to the hospital level. And for example, as a project, you have to adapt to that, looking at how you fit into these new models of care, almost to the point where you're trying to predict where models of care can go. I don't know if you want to add anything to models of care, Adrian. I know you've been involved much more in that than I have.
No, I think that as Paul is saying, we're getting close to our end.
Sorry.
So rather than sort of
sorry about that,
put that back in his hand, and maybe that's a conversation for a beer later.
I can't see any hands up or anything more in the chat. It's kind of pretty much right at the end, but if there's a very, very quick question, we could take it if anyone's got anything burning to ask. If not, I'll thank you both for the talk. It was brilliant. It was really interesting. It's really good to have a perspective from an organisation like Hitachi. I hope that we can continue to engage with you in different ways, and I hope that the audience has enjoyed it, and I hope you come back. I don't think, Craig, that we have a date for another seminar, but we'll disseminate the invitations in the usual way when we have. But yes. Thanks very much, and
thank you everybody for attending.
Thank you very much. Appreciate it.
Have a great summer, everyone.
You too. Have a great evening. Bye. Thanks. Bye.